All right, welcome back to The Explainer. Today, we're going to dig deep, I mean really deep, into the ground right under our feet to understand the incredible forces that shape our world, tectonic plates, and the very rocks that make up our planet. So let's get into it.
So let's start with a kind of a wild idea. We tend to think of the ground as, solid, stable. But what if it wasn't? What if the very surface of our planet was actually a collection of giant, constantly moving puzzle pieces?
To really get our heads around this, we've got to peel back the layers of the Earth, kind of like an onion. We need to see what's going on deep beneath the surface.
So here's the basic breakdown of our planet. Way down at the very center, you've got a solid inner core made of metal. Around that is a liquid outer core. Then you have the mantle, this massive layer of hot, molten rock we call magma. And finally, on the very outside, that's us, living on this thin, solid crust.
Now here is a key term for you, the lithosphere. This is basically the crust and the very top solid part of the mantle all fused together. The best way to think about it, it's like the Earth's hard, fragile eggshell. And that shell is what this whole story is really about.
Okay, so we've got this eggshell, right? But here's the twist. It's not one solid piece, not even close. And this is where things really start to get interesting.
You see, that lithosphere is actually cracked into a bunch of massive pieces that we call tectonic plates. Every single continent, every ocean, they're all just sitting on top of these plates, kind of like passengers on giant rocky rafts that are floating on that semi-molten mantle just below.
So how fast are these giant rafts moving? Well, you're not going to feel it. We're talking about just a few centimeters a year. Seriously, it's about the same speed your fingernails grow. It doesn't sound like much, I know, but you give it a few million years, and that's more than enough time to completely rearrange the globe.
So if these massive plates are constantly moving around, the big question is, what happens when they bump into each other? Because that's where all the action is.
Right, the plate boundaries. This is where mountains are literally born, volcanoes erupt, and the ground shakes. It's the geological hotspot of the planet. And it all really comes down to three main ways these plates interact with each other. First up, you've got what's called a convergent boundary. This is a head-on collision. Two plates move towards each other, and bam! Often, one is forced to slide underneath the other. This is exactly how you get epic mountain ranges, like the Himalaya.
Next, you have the total opposite, divergent boundaries. This is where plates are pulling away from each other. They're literally ripping apart. And when they do, magma from the mantle just oozes up to fill the gap, creating brand new crust. A lot of this happens deep under our oceans.
And the third type? Transform boundaries. Here, the plates aren't colliding or separating, they're grinding past each other horizontally. Imagine two giant pieces of sandpaper rubbing together. All that friction builds up incredible amounts of energy, and when it's suddenly released, that's an earthquake. The San Andreas Fault in California, a classic example.
Okay, this chart is a fantastic summary of everything we just talked about. But if you look at that effect row, that's the real takeaway. Divergent boundaries are constructive. They make new land. Convergent are destructive. They consume land. And transform boundaries, they're conservative. Nothing's made, nothing's destroyed, which is also why you usually don't see volcanoes there. It's all about that sideways grind.
So we've got a pretty good handle on how the Earth's crust moves. But what is this crust? What are these massive plates actually made of? Let's zoom in even closer.
It all comes down to rocks. The crust is basically made of three main types of rock. And you know what? Each one has its own origin story that ties right back into all this dynamic plate action we've been talking about.
Yep, igneous, sedimentary, and metamorphic. These are the three fundamental building blocks of our planet. You've probably heard the names before, but how they're actually formed is a pretty amazing story.
Let's start with igneous. Think ignite. This is rock born from fire. It's literally just cooled down molten rock. And here's a great little reminder for you. When that molten rock is underground, we call it magma. Once it erupts onto the surface from a volcano, we call it lava. But when either one of those cools and hardens, boom, you've got igneous rock. Next up, sedimentary. I love this one. It really is like a geological scrapbook. It's made from tiny little pieces of other rocks, sand, pebbles, shells, you name it, that all get deposited in layers. Over millions of years, the sheer weight from all the layers above squishes them together into solid rock.
And last but not least, we have metamorphic rocks. These are the ultimate transformers of the rock world.
They start out as either igneous or sedimentary rock, but then they get subjected to insane amounts of heat and pressure, usually deep underground, often near those chaotic plate boundaries. This completely changes them, transforming them into something new.
But here is the coolest part. These three rock types, they aren't in their own separate boxes. They're all connected in this incredible, never-ending cycle of transformation.
And here it is, the rock cycle. You can think of it as Earth's ultimate recycling program. It shows how the very same forces that move entire continents, all that melting, cooling, pressure, and erosion, are constantly, and I mean constantly, changing one type of rock into another.
The key thing to get here is that any rock to become any other type of rock. It's a non-stop loop. So, for example, a volcano spits out some igneous rock. Over time, it weathers away into tiny bits of sediment. That sediment gets buried and squished into sedimentary rock. If that rock gets pushed deep down at a plate boundary, the heat and pressure bake it into metamorphic rock. And if it gets pushed down even further, it melts back into magma, and the whole cycle is ready to start all over again.
So what does this all mean? It means the ground beneath our feet isn't solid and permanent at all. It's part of this epic, slow-motion ballet of creation and destruction. The continents are shifting, new rocks are being born, old ones are being recycled. It really makes you wonder, doesn't it? What will our planet even look like in 50 million years?